So let's talk about summations and see how they apply to area. So a summation is when we take a bunch of numbers and add them up. That's a summation. So like if we add up the first 100 positive integers, we've seen that we can get, this is 5050, 5050. Okay? So that's a big summation. If we want to write that quickly, then we can write it like this: the sum as I goes from 1 to 100 of I. And what that means is you take the first number, and it's just I, and that's 1, and then the next number is 2 and 3, and all the way up to 100. So this means add all the i's up, okay? And that's our sigma notation there. Just a quick way to write a bunch of things added up. Now, in order to work with summations, we want to be able to look at some common patterns that show up often and to be able to find a formula for them, all right? Because we don't want to necessarily add them up every time. We want to find a quick way to do this. Well, if we add up some even numbers, like let's say, what happens if we add up the first one even number? Well, that's just 2, right? What if we add up 2 even numbers? So this is the amount of terms or the amount of even numbers, okay? So if we take 2 and we add, so the first 2 even numbers are 2 and 4. If we add those up, we get 6. If we add up the first 3 even numbers, 2 plus 4 plus 6, we get 12. All right, now how about the first 4 even numbers? Well, add on 8 to that, we get 20. Add up the first 5 even numbers, well, that means 2 through 10, and we're going to get 30, so on and so forth. So the question is, what's the pattern that can help us to jump to 100? Take a look. Do you see it? So we've got 1 goes to 2, 2 goes to 6, 3 goes to 12. And you can look at it this way. There's not much pattern there, going up by 4, up by 6, up by 8. Of course, that's just those numbers, but look at the numbers going down this way. So if we look close, we should see this is like 1 times 2. This guy is like 2 times 3. This is 3 times 4. 4 times 5. Aha. So it's always multiplying by 1 more. So this guy is going to be 100 times 101, right? And that's going to be 10100. Okay? And so we're always taking the number and multiplying it by 1 more. So that's n, let's try that again. So that is n times the number that comes after n, and that's n plus 1. Okay? So there we have a formula. So if you want to find the sum of the first n even numbers, we can just use this formula, and you've got your answer. Don't actually have to add them all up. That's handy. All right, so what about the sum of the first 100 natural numbers? Well, that's what we did. Natural numbers are like 1, 2, 3, 4, 5, okay? So if we got the sum of the first 100 natural numbers, we got the first, if we take one natural number, the first natural number is 1, and add that up, well, that's just 1. If you take 1 plus 2, that's the first 2. So if we add up the first 2 natural numbers, we get 3. If we add up 1 plus 2 plus 3, that's going to give us 6. 1 plus 2 plus 3 plus 4 is going to give us 10. 1 plus 2 plus 3 plus 4 plus 5, well, that's going to give us 15, because it's just adding 5 more to what we had before, right? Okay. Well, is there a pattern there? Not necessarily, okay? If we look at this by itself, it's kind of hard to see the pattern. What do you do to 1 to get 1? Well, there's lots of things. 2 to get 3, 3 to get 6. I don't know. But let's take a look at this. Look at this number up here, 2, and this number down here, 1. Okay? Take a look at 6 and 3, 12 and 6, 20 and 10. Do you see a relationship there? These guys are always half of these ones up here. Okay? And so that's a useful connection. Okay? So if we can find out what the natural number is, I'm sorry, the sum of the even numbers, then we cut it in half and we get the sum of the natural numbers. Kind of makes sense there. So this is going to be half of this one for the 100th. Well, it's 100 times 101 give us this. Now we're going to cut that in half. Half of 10,100 is 5,050, which is what we found on the then when we add them up, kind of using a pattern there. All right, so 5,050. So what's going on? Well, we're taking these numbers and we're cutting them in half. Okay, so if I take what we have up top, that's n times n plus 1, and we're going to divide that by 2. So n times n plus 1, and we're dividing that by 2. Okay? These numbers show up all the time, okay? So we got some special names for these. These guys right here, these are called oblong numbers, or sometimes we call them rectangular numbers, okay? And these guys, we've got like a 1 by 2. We've got a 2 by 3. And if we kind of picture rectangular arrays, the next one's a 3 by 4. Okay? So these are always going to make rectangles, nice, neat rectangles that are one longer than that. These guys are called triangular numbers. Okay? Triangular numbers. Okay? And, well, they make triangles. And, well, we'll see that more later on, okay? We'll leave it at that, okay? Well, I guess it won't hurt. Let's do this. If we take the first number, that's 1. If we had 1 plus 2, we could draw it like that. If we take 1 plus 2 plus 3, we get a nice triangle like that. 1 plus 2 plus 3 plus 4, we get a nice triangle like that. Okay, 1 plus 2 plus 3 plus 4 plus 5, we get a nice triangle. Okay, so adding up those dots gives you a triangular number, okay? All right. So what about the first 100 odd numbers? Well, let's try that out. First odd number is 1. So you add that up, you get 1. 1. 1 plus 3. Well, that gives us 4. If you add 1 plus 3 plus 5, these are odd numbers. We get 9. 1 plus 3 plus 5 plus 7. That's 16. And then if you add 9 to it, you get 25. Okay? Do you recognize those numbers? Hope so. You've used those before. This is just 1 squared. So if we take 1 and we square it, we get 1. If we take 2 and we square it, we get 4. Take 3 and square it. Take 4 and square it. Take 5 and square it. Get it? Got it? Good. All right, so we square this and we get our answer. This is just 100 squared, which is 100, 10,000. So when we add up odd numbers, we just get a square number, n squared. Okay? All right. One more pattern, okay? What happens when we add up the first n square numbers? Okay, here they are, kind of filled in for us, okay? So this is adding up 1, 1 plus 4, 1 plus 4 plus 9, 1 plus 4 plus 9 plus 16, so on and so forth, and we add 25, okay? So adding up a bunch of square numbers gives us 1, then 5, then 14, then 30, then 55. This one's kind of tough to see the pattern, so we're going to go ahead and just tell you what it is. This guy's going to be n times n plus 1, that looks familiar, times 2n plus 1, which is an odd number, all over 6. All right? So, well, you can investigate that and kind of see if you can kind of prove that there. So, but that's a formula we'll want to use often. So that ends up being 100 times 101 times 2n plus 1. That's going to be 201 all over 6. And this is going to actually work out pretty nice because let's see. 2 goes into there 3 times, 2 goes in there 50 times, and 3 goes into there once, and 3 goes into 201 67 times. All right, well, let's see what that is. And that is 338, 350. Okay, big ugly number.